Okay, here we go, Precalculus. The second day of the law of signs involves something called the ambiguous case. Um, that's when the information you're given doesn't just describe one triangle, it could describe a couple of triangles possibly. So we've got some scenarios to break down, and you got a little bit of work to do as far as getting some experience with these so you can pick when you have to find information for a second triangle. Okay, let me explain what I'm talking about here. For A, B, and C, I'm just going to put sides there, and then we'll go little a and little b and little c across from them, of course. The law of signs can be used when the information given to you about the right triangle is in the following orders: angle, angle, side, angle, or let's see, angle, side, side. Which, of course, not many math teachers would call it that way, but the ass triangle is the one that we have to look out for because there may be two triangles. So I like pointing out that way because it jumps out at you. You know, you're going to remember that, and you're going to have to remember, okay, this is an angle, side, side triangle. I need to look to see what scenario I'm in. Okay, that's what's going on there. So here's an example of an angle side triangle. We'll say that angle C is equal to 80 degrees, so I'm up there with that top angle, and angle B is equal to 16 degrees, so there's an angle and there's an angle, and we'll say side C is 4.6 inches, right? I don't want to solve that triangle. You guys did that in the last section, and you should be getting pretty good at it. I mean, the law of signs is, once you get a handle on it, it's actually pretty easy to do, I think. Angle, side angle. So let's go with angle A is maybe 32 degrees. Angle, side angle. So the next thing I would want is like maybe this angle, this side C down here. Side C is 54 feet. I'm just making stuff up here as I go. So angle and then side and then angle. So maybe angle B is 18 degrees. Okay, angle, side angle versus this last one, angle, angle, and then side. If you got two angles, you have the third angle, right? If you have two angles, you have the third angle. So you definitely have things across from each other, even if you have to go find them. Like I've got angle C and I've got side C. I don't have angle C here to match up with this side C that I've been given, but I can subtract from 180 and get angle C, and then I have things across from each other for one of my fractions, right? The angle side triangle goes like this. Angle A is equal to 42 degrees, and side A across from it is 12.5, and side B, another one of the sides, is 6 inches. So look what's going on here. Angle A, side A, and side B. So angle and then side and then side. You see what I mean? Angle, side, side. When that happens, there are scenarios like this one where it's not just one triangle. The ambiguous case comes in the order angle, side, side. Of course, easy to remember. As in, angle A is 42 degrees, side A is 12.5, and side B is 13 inches. 12.5 and 13. Okay, so let me draw what's going on. I'm going to do my best accurate drawing, so work with me here. I don't know how long that side is. This is going to be a 42 degree angle, so let me try and draw a 42 degree angle. You know, it's kind of like half of a quadrant, right? 42. And then, if this is angle A, so side A would be over here, and I'm going to say that this is angle C up top, okay? And then side B is, angle B is down here. I don't know what angle B is, but I know that this side is 13. And I know that side A is 12.5. Now here's the thing. That 12.5 is just a little bit shorter than this one, right? So it swings down here. Is it 12.5 here to create the triangle? Or, if I swing this out this way, is it 12.5 here to make the triangle? You see what I mean? If it's shorter than 13 and it's long enough to make a triangle happen, it could be two different triangles. It could be this one, or it could be this one. You guys see what I mean? So there's 13 and there's 12.5. Oops, I spelled that wrong. 12.5, and then there's angle A. And so if you look real close, like this is where angle B would be. That's acute. That's obtuse. That's acute. That's obtuse. And so we don't know any more information other than these three pieces of information. So when they come in the order, angle, side, side, and under a certain circumstance, you actually have to solve two different triangles. That is what we're wrestling with today. All right, let's go to page 2. Now that we kind of see how it's possible, hopefully my drawing made sense to you there. Let's break this down a bit. So if you're given angle A, side A, and side B, you know, or like maybe angle B and side B and side C, right? Or we could go angle C and side A. Basically, an angle and a side across from each other, and then another side. Like, isn't that what we're talking about here? Okay. There are three possibilities in this angle side scenario. It's possible that there's one triangle. This can happen in two different ways as far as like the sizes and the orders of things. It's possible that there are two triangles. There's only one way that can happen, and I just showed it to you on the other page, but we'll break it down further. Or it's possible there's no triangle at all. That can happen in two different ways. Okay, so we've got 5 little scenarios here, right? To make sense of this, let's break down the information you were given this way. If angle A that you're given is an obtuse angle, now that's not like the one that I drew. If angle A is obtuse, it's bigger than 90 degrees, there is either one triangle if side A is long enough to make it happen, or there's no triangle if side A is not longer than, let's call this side B. If side A is shorter than side B, you can't make a triangle out of it, right? Number 2, if angle A is acute, like the one that I drew on the other page, if it's an acute angle, all 3 of those possibilities exist. So your first thing to do, once you figure out that you have an angle side triangle, is to break down the one angle that you have. Is it obtuse or is it acute? Okay, so here is scenario 1. If the angle that I'm given is an obtuse angle, and that's side B, and side A is, you know, that's the one across from the angle you're given, of course. If A is greater than B, there is one triangle, and you can just solve it like we did in section 8.1, day 1, 8.2, day 1. But if A is less than B, there is no triangle at all. All right, so here we go. I got an example for you. Let's solve a triangle. If angle A is equal to 100 degrees, and side A is equal to 15, and side B is equal to 8. Okay, if the opposite side is longer than the other one given, then yeah, I can make a triangle out of this. You guys see how it works? Okay, so then this is just your normal solve a triangle stuff. So I'm going to go the sine of 100 over 15 is equal to the sine of angle B, and that's going to be over 8. I'm going to do my cross multiplying and skip a step here, and I'm going to say that the sine of angle B would end up these two times each other, 8 times the sine of 100 and divided by 15. So angle B ends up being the inverse sine of all of that hot mess right there. So I'm going to go to my calculator, make sure that I'm in the right mode. I'm in degree mode, that's good. And then I'm going to hit inverse sine of 8 times the sine of 100. I'm going to close parentheses, and I'm going to divide by 15. I get 31.7 degrees. Angle B is 31.7 degrees approximately. So I had to find angle B, that's 31.7. I got to find angle C, and I got to find side C. Well, if we got angle A 100 and angle B is 31.7, I could just go 180 minus 100 minus 31.7. I get 48.3 for angle C. And then I got to find side C. So I start the same way. I'm going to use the angle A stuff I was given. Sine of 100 over 15 has got to be equal to the sine of this 48.3, and that's going to be over side C. I didn't leave myself a lot of room to work here. C ends up being, again, I'm going to skip steps. It would be these two times each other and then divided by the sine of 100. So I'm going to go 15 times the sine of 48.3. I'm going to divide by the sine of 100. All right, put that in the calculator. 15 times the sine of 48.3. I got to close my parentheses before I hit divide. And then I put the sine of 100 in the denominator. And I get 11.4. 11.4. And remember, the biggest side should be across the biggest angle. So you have an obtuse angle here, and then I have 15. The next two sides are 8 and 11. They're not bigger than 15, so it seems like things are working out pretty good. The smallest angle is 31.7. The smallest side is across from it at side B, so we did a good job with that one. Now, if I tried this and A was shorter, I would get an error. I don't really have... I don't know if I have an example of that, but I want you to see it. So here, I'm going to do another problem real quick. Angle A is equal to 100 degrees, and side A is 12, and side B, let's say, is 14. Okay, so what's going on here is I have 100 degrees, that's angle A, and then this is side B, and it's 14, and this would be angle C up here, and what's going on is this is only 12 units long. And so it can't make it back to even here to make a line, much less be out here and finish off the triangle. So watch what happens. I'm going to go the sine of 100 over 12 is equal to the sine of angle B over 14. It looks like it's fine. I cross multiply and I get the sine of B is equal to 14 times the sine of 100 divided by 12. So B should be the inverse sine of all of this. Well, look what happens, guys. 14 times the sine of 100 divided by 12. That's bigger than 1. You can't have an angle whose sine is bigger than 1. So if I try to put this in here, inverse sine, I go 14, and then it's times the sine of 100, and then I divide by 12. What happens is I get an error because it's not possible. The triangle is not possible. So frequently, if you try and solve something where you shouldn't be solving anything, you get an error out of the calculator anyway. So that's kind of a nice thing. It tells you if you're doing something wrong. All right, that was scenario 2. That is what happens if we have an obtuse angle. Scenario 2. Let's see. If that's where we have an acute angle, we need to compare the length A with another length that I'm going to call H. And that's an altitude from the end of side B. Okay, let me explain again. So I'm going to keep drawing this with angle A down on the left side there. And if this is side B and I've got this opposite side A, okay, it's got to be a minimum length that I got to have here. So what I'm going to do is I'm going to draw an altitude, a right angle H. That H is the shortest distance that A could possibly be. You see what I mean? A has to be that long or longer to make a triangle. The way I drew it, A is shorter than H, and it can try, but it's not going to make it. It's not going to make a triangle happen. So since the altitude creates a right triangle in here, I can go the sine of A is equal to opposite over hypotenuse. I can say the sine of angle A is equal to H over B. And so if I want to know how big H is, I'm going to call it B times the sine of A. If I want H by itself, I'd multiply by B, right? So if the angle you're given in the angle side-side triangle is acute, not obtuse like the last page, and side A is, look, I got two possibilities here. If side A is less than B sine A, there's no possible triangle. A is not long enough to make the triangle happen. So here's an example of that. I'm going to say angle A is 63.4 degrees, and side B is 10.5 inches, and side A is 9 inches. Okay? It's an angle opposite side and another side. So it's an angle side-side scenario, and we have an acute angle. So it's not obtuse. That makes it harder. So we should check this B sine A thing. Okay? They have to be in the order A, B, and C, right? So, I mean, this changes if we're given a triangle with like D, X, and G in it. You know what I mean? So, in this scenario, I'm just going to go B sine A. I'm going to say 10.5 times the sine of 63.4, and I'm going to see how long the minimum is. This is the minimum I need in order to make a triangle happen with an angle A of 63.4 and a side B of 10.5. Okay, so I go into the calculator. I'm going to get rid of this error that I was trying to do with the other wrong triangle. And I go 10.5 times the sine of 63.4. It's 9.388. It's 9.388. Now look at side A. It's not long enough. Side A is too short. It's like this picture. It's like this height right here is 9.388, and this little 9 inches or whatever that is trying to make it to the other side of the triangle. Can't do it. There is no triangle. That's our answer. There is no triangle. Now, if I'm going to tell you that I don't think you need to do this in the middle of this problem. Here's why. You could just start trying to solve it and run into an error on your calculator and go, oh, it's not long enough to make the triangle. Watch. I'll go sine of 63.4 over 9, the one that's opposite, and then I'm going to go the sine of angle B over 10.5. Right? I just set it up without even checking this and start trying to solve the triangle. What I'm going to end up with is that the sine of B is supposed to equal 10.5 times the sine of 63.4, and it'll all be over 9. And so when I go inverse sine of 10.5 times the sine of 63.4, close my parentheses and divide by 9, I get the error. What that means is this wasn't long enough in the first place. So you got to come up with the answer as no triangle here. Whether you do it by remembering to check this, even though the letters will change if you're given different information. You can do it that way, or just start trying to solve it, and if you get an error, go, you know what, there's no triangle. I think that's the better way to go. Okay, now number 2. I've got an acute angle. It's an angle side-side triangle. I've got an acute angle, and if A is actually equal to B sine A. If this A is the same length as this, it's only going to reach in this one spot. There is only one triangle, and in fact, it's got to be a right triangle. So I don't even need the law of sines. I could use SOHCAHTOA type stuff. So look, if A is equal to 30, and B is equal to 10, and A is equal to 5. Okay, 30 degrees, B is equal to 10. So I'm just going to start, well, let's do the B sine A thing, just so you guys see what's going on. So that would be 10 times the sine of 30. You guys, the sine of 30 degrees is 1/2, isn't it? Don't we know that from the unit circle? That's 10 times 1/2. So the minimum distance A needs to be is 5, and it is exactly 5. And so what that means to me is that this is a right triangle. In fact, it's a 30, 60, 90 triangle, isn't it? Right? So I go sine of 30 over 5 is equal to the sine of angle B over 10. And I get the sine of B is equal to 10 times the sine of 30 over 5. And so B will be the inverse sine of this. Now I feel silly even doing this because I know what kind of angles I'm getting out of this. It's a 30, 60, 90 triangle, right? But I'll do it anyway. Second sine is 10 times the sine of 30. Finish the parentheses and divide by 5. And I find out that B is the 90-degree angle. Okay, so angle B is equal to 90. That means angle C has to be the 60-degree angle. And if I'm looking for side C, I could use what I know about 30, 60, 90 triangles, or I could use the law of sines again. I'm going to get 8.7 for C. Okay, it's basically going to be 5 square root 3, right? Isn't that how that works in a 30, 60, 90 triangle? Anyway, let's go on to the next page. So let me back up a second. We're looking at angle side-side triangles. The first page we looked at the obtuse version, and that one's pretty straightforward. There's either one triangle or there's no triangle. If it's acute, we got to check to see if A is long enough. It's possible there's no triangle. If A is exactly long enough, there is only going to be one triangle, and it's a right triangle. And so here we go on to the next page. And let's see what happens. I think this is our last page, right? This is our 4th page. What happens when, see how I'm doing in your picture here. A is greater than B sine A, but A is less than B. Okay? This is where there are two triangles. There's one with an acute angle B, and there's another one with an obtuse angle B. The first thing you find in an angle side-side triangle, since you have two sides and an angle across, is going to have to be the second angle. Angle B in my scenario here, but it'll always be an angle that you find first. That's the one that could be acute or could be obtuse. Now, here's the thing. The calculator, when you hit inverse sine, goes from negative 90 to 90. So the calculator will give you the acute angle. The calculator will not give you the obtuse angle. All right. Here we go. I'm going to tell you that angle A is 38 degrees, and I'm going to give you a side A of 6.5 and a side B of 8. By the way, if side A is longer than B, it's just one triangle. Like we did that in the last section. Okay, it's an angle side triangle. It's not an obtuse angle, it's an acute angle. This is the scenario we got to look out for. Angle side, acute angle. Now, I'm not even going to bother with B sine A because, one, you got to switch that formula up with letters if you're given stuff in different order, and two, if it doesn't work out, the calculator will just give me an error. Okay, so I'm going to start solving the triangle. The sine of 38 over 6.5 is equal to the sine of angle B over 8. Okay, I'm going to find angle B first. But here's the thing. When I hit inverse sine for this, the calculator has to give me from negative 90 to 90. And I'm using all positive numbers, so it's going to give me something in the first quadrant, an acute angle. Okay, so B is going to be the inverse sine of 8 times the sine of 38 over 6.5. I just skipped 2 steps there, right? Aren't we supposed to cross multiply and then isolate the sine of B and then take the inverse sine? But we've done it enough times where hopefully me going from this step to that step is not throwing you too far. I would cross multiply and then I would divide to get sine of B by itself, and then I take the inverse sine. So here we go. The inverse sine of 8 times the sine of 38 divided by 6.5 is 49.3. Angle B is 49.3. So I'm going to put 49.3. And every time you guys do one of these, I want an asterisk next to the first angle you solve. Because the second triangle, I'll have angle A is 38, and side A is 6.5, and side B is 8. But angle B, well, I just did that in kind of a stupid way. That's all right. Angle B will be something else the next time around. Okay? Now, if I've got angle A and angle B, I can find angle C. That'll be my next thing to find. So I'm going to bring the calculator and go 180 minus 38 minus the 49.3 that I found. That's 92.7. So apparently angle C was going to be an obtuse angle here. Now to go find side C, I'll do my little thing where I put these in boxes, right? Okay, so I'm going to go the sine of 38 over 6.5 is equal to the sine of, I just found 92.7 for angle C, and that'll be over side C. And so I'm going to shorten up my work here again, and I'm going to say C will end up equaling these two times each other, 6.5 times the sine of 92.7, and it'll be divided by the sine of 38. Okay, so let me go to my calculator, 6.5 times the sine of 92.7, close my parentheses, and that's divided by the sine of 38. I get 10.5 for side C. Should be the longest side because, and it is, because it's across from the biggest angle. Now, what happens with this angle B situation? I'm gonna tell you that these two add up to 180. That's gonna be the only thing you really need to know. But I'm gonna box this work off and I'm gonna show you something. If I have angle A like this, and there's my side B, and I'm gonna have an angle B down here. Now, if side A comes out this way, which is what happened here, and we got a 49-degree angle, but if I bring side A in here to get this obtuse angle, look what you have. You have an isosceles triangle, right? And those two have to be the same. So right here, where the angle B is that you're looking for, this obtuse angle, that angle plus this one, which is congruent to the first one we got, they have to add up to 180 because they make a straight line. So that means, since these two are the same, this angle B and this angle B have to add up to 180. It's an old geometry trick. And so my other angle B for my other triangle, this is going to end up being 180 minus the 49.3 that I found from the calculator. That will be an obtuse angle. 180 minus 49.3 is 130.7. Now that's the obtuse angle. Angle C can't be an obtuse angle now. So angle C won't be the longest side anymore. The three original pieces of information will stay the same, but all three of these will change. Okay? I think recognizing the scenario is the hard part. The rest is not hard at all. So I just go find my new angle C. 180 minus 38 minus 130.7 ends up being 11.3. Angle C is a tiny little baby 11.3 degrees. And it should make sense because angle C is up here at the top. When this thing comes in here to make angle B an obtuse angle, look how small that little angle gets up there. Okay, my last thing to do for the second triangle is find side C here. So I'm going to go down and I'll write sine of 38 over 6.5 is the sine of angle C is now 11.3 over side C. And the rest I think is pretty easy. 6.5 times the sine of 11.3 over the sine of 38. Go to the calculator and put in 6.5 times the sine of 11.3 divided by the sine of 38. And I get C is equal to 2.1. And so this little tiny side C is 2.1. So there is triangle number 1 with the original 3. And here is triangle number 2. Your job is to recognize when you're given an angle side-side triangle. If you have an acute angle and A is smaller than B, but big enough to make the triangle happen, you're going to get two different triangles. How do you get the second triangle? The first angle you find, you got to subtract it from 180 to get that angle for the other triangle. That's a lot. That is a lot for you guys to process. So I'm going to give you guys a few homework problems. The biggest key for you is recognizing when you get an angle side-side triangle, and then break it down. Is it acute or is it obtuse? When it's acute, that's the problem child. So you got to look to see what scenario you're in. All right? I'm going to put homework on my math lab. And then probably I think we can plan tomorrow on a day where we just solve triangles. I don't think we need to do any new notes. It'll be a solving triangle bonanza tomorrow. All right? Have a good day, everybody.